Okay, good morning. This is day one of arithmetic and geometric sequences and series. So we're going to start today by talking about the arithmetic sequence. So one of the goals for this unit is that you know the difference between a sequence of numbers and a series of numbers. So remember, a sequence is just a list of numbers in which each successive term is found by adding a common difference. So each successive term, you could think of this as the word next. So the next term is found by adding a common difference, and we call that common difference D. Okay? So to find D, subtract the first from the second. So you do second minus first, and if that number is equal to the result from when you subtract the second from the third, then you know that it's going to be arithmetic. So if the result is not equal, then the list of numbers is not arithmetic. So one of the first things you're going to have to do in this unit is, given the list of numbers, determine whether it's arithmetic or geometric. And we'll talk about geometric in just a minute. So for example, if I had the list of numbers, say it was 1, 3, 5, 7, okay, what you'd have to do there is you'd be like, okay, here's this list of numbers, so it's a sequence of numbers. And you're trying to figure out how are these numbers related to each other. So how did you get from 1 to 3? How did you get from 3 to 5? And how did you get from 5 to 7? Well, in this case, it's easy to see that your common difference is 2, because if I take 1 plus 2, I get 3. And then 3 plus 2, I get 5. 5 plus 2, I get 7. And so what this is saying in this paragraph here is that if you do 3 minus 1, you get 2. And 5 minus 3, you get 2. So since you get 2 both times, this is indeed an arithmetic sequence. There are two formulas that we're going to use primarily with the arithmetic sequences, and you will get a formula chart for this test. You will get a formula chart for the test. So one of the formulas you're going to have to use is the explicit, and the other is called the recursive. Now, I would put a big star next to the explicit formula. That's the one that you are going to use most of the time. So when in doubt, try to use that explicit formula. And what this formula says is that to get any term in the sequence, that is going to equal the first term plus the common difference multiplied by whatever term number you're trying to find minus 1. So going back to this example here, say this would be your first term, that would be your second term, your third, and your fourth. Well, let's just say I wanted to figure out the fourth term there, even though I already know that it's 7. But let's just say I was trying to find a sub 4. You'd read that as the fourth term. And so the fourth term, it says that term is going to equal the first term. Well, in this case, my first term happens to be a 1. So it would be 1 plus the common difference. We already determined in this example that our common difference was 2. So it would be 2 parentheses. Now this is, what term was I trying to find? Well, I was trying to find the fourth. See how this 4? I was trying to find the fourth term. So a sub 4 means the fourth term, but my n, the term number itself, was 4. So 4 minus 1. And then if you go through and do this, let's see, 4 minus 1 is 3. 3 times 2 is 6. And 1 plus 6 equals 7. So obviously here it was easy just to kind of keep adding 2, adding 2, adding 2. But this formula would be extremely useful, for example, if you were trying to find the 200th term. Obviously, if you wanted to find the 200th term, you wouldn't want to keep adding 2, adding 2, adding 2 forever and ever there until you got to the 200th term. It would be much easier just to plug in, you know, a 200 here, a 2 there, and a 1 there to figure out what your 200th term would be. So your notes here, it says use this when you're asked to find a specific term. So yeah, if they ask you to find the 112th term, here I found the fourth term, but it's, you know, the larger the term number, right, the more useful that formula is, because otherwise you'd just be able to use the list of numbers. Okay. The next one that you want to use is the recursive formula. So the recursive formula, I kind of call it the duh formula, because it says that if a sub 1 is your first term, and a sub n plus 1, so the next term, right? It says to find any term, you take the term right before it, and then you add the common difference. So why do I call this the duh formula? Because basically this says to find the fourth term, you need the third term, and then you add the common difference. Well, to find the fourth term, the 7 here, it would say you'd take this and you'd add the common difference. So the limitation of this formula would be, well, you need the term right before it in order to be able to use it. So this is kind of more used when you're just writing general formulas, and that's when you'll know to use that, is they'll say, write the general formula to kind of show the pattern. And that'll kind of give you an idea that maybe that's a recursive. But again, if you are going to know how to use one of these, I would definitely make sure you know that that explicit formula, that's going to be the one that you're going to be using most of the time. Okay? All right, so we'll just kind of scooch this up, and then we'll switch to talking about geometric. So a geometric sequence, again, a sequence is just that list of numbers, and they're related by finding the next term by multiplying by a common ratio, and we call that common ratio R. So in order to find R, because one of the things you'll have to do is be able to find R, and you, again, are going to look at those first two terms. This time you're going to do second term, you're going to divide the second term by the first. So you do second divided by the first. And then you check that with the third divided by the second. And again, you want that number to be the same. If it's the same, then you could say that you have your common ratio. So again, I'll just use another simple example. So say the list of numbers, or the sequence of numbers that you had, say it was 3, 6, 12, and then 24. Okay? So say you were given this list of numbers, and I'll just write the example right there. So here, a sub 1, your first term would be 3. Your second term would be 6. So it says to find your R. Now, again, most of you can just look at this and say, oh, look, to go from 3 to 6, the relationship there is you multiply by 2. To go from 6 to 12, you're multiplying by 2. And to go from 12 to 24, you're multiplying by 2. Most of you can see that right away. But why, when these get a little bit trickier, kind of the way to check it to make sure is you're going to take 6 divided by 3 gives you 2. And then you'll say, well, does 12 divided by 6 also give you 2? And in this case, it does. So that tells you that your common ratio is indeed 2. So once you determine it's geometric, okay, then you'll be able to use formulas just like before. So again, the first thing you want to do in this unit is take a look at the list of numbers, and you want to determine, is it geometric or arithmetic? Now, notice sometimes you'll be given a list of numbers that's not geometric or arithmetic. For those, you're going to have to kind of figure out your own formula. So for example, if I give you the list of 1, 4, 9, 16, 25, right? That list of numbers is not geometric or arithmetic, because to go from 1 to 3 or 1 to 4, you add 3 or multiply by 4. But if you look at how to go from 4 to 9, well, you add 5 or multiply by 2 point something. So this is an example of a sequence of numbers that is not geometric or arithmetic. Here, your formula would be, it would just be n squared, right? 1 squared is 1, 2 squared is 4, 3 squared is this. So here, the formula, that's what I mean by you'll have to write your own formula for that, okay? So again, the first thing you do in this unit is try to determine, you look at your list of numbers and determine, is it arithmetic or geometric? And then from there, you can apply the formulas. So just like before, you have an explicit formula and a recursive formula. So you want to try to use the explicit formula more often. You use it when you're trying to find a specific term. So if it says find the 4th term or the 32nd term, you're going to use this formula. So let's just try this formula on this simple example. And again, I'm just going to find the 4th term just because I didn't feel like going any further. So we'll say, for this example, if I'm trying to find a sub 4 in that list of numbers, even though I already know that it's 24 just by looking at it, but say I only know the first couple, we'll just check the formula. So it says to find the 4th term, you say that that equals the first term. In this case, my first term, my a sub 1, is 3. So it'll be 3, parentheses, r raised to the n minus 1. My common ratio we determined was 2. And then I'm trying to find the 4th term, so this would be 4 minus 1. So in this case, it's going to be 3 times, well, 4 minus 1 is 3, so it's 2 to the 3rd. The most popular mistake people make here is that they multiply these two numbers together. You cannot not do that, okay? you may not do that. That is against the rules of PEMDAS. You need to make sure that you're taking this 2 and raising it to the third power first. So it's going to be 3 times 8, which would give you 24. Okay? Notice that if you didn't do that, you'd get 6 to the third power would not be 24. So here, and you can, of course, see that your answer checks. And again, obviously the 4th term was simple. I could have just done here, but what if I asked you for the 14th term? Well, it would be much easier to use this formula than to kind of keep multiplying by 2, you know, another 10 times or so. Okay? All right, and then just like there was a recursive formula before that I called the O-duh formula, it's kind of the duh formula for this. It says if a sub 1 is your first term, then to find any term in the sequence, you take the term right before it and you multiply it by r. So again, to find the 4th term, it says you would need the 3rd term multiplied by 2, which again is sort of useless for us. Okay, so there is page 1. Okay, so on to page 2 now. There are 8 examples, and we're going to kind of go through each example and see what we can come up with. Okay, so let's take a look at example 1. And in example 1, you're given this sequence here, -6, -2, 2, comma, dot, dot, dot. So that means that this sequence keeps going on and on and on. And it says write an equation for the nth term. So when you're asked to write an equation for the nth term, that means that there's going to be an n in your answer. That's different, for example, that you see later down in like example 5 where it says find the 11th term. So if they ask you for a specific term number, your answer is going to be a number. But if they just ask you to write a general equation for the nth term, that means n is going to be in your answer. So again, the first thing we want to do is to determine how is this list of numbers, how is this sequence of numbers related? So how do you go from -6 to -2 to +2? Well, it looks to go from there to there, you add 4. And then if you add 4 again, you get to there. So since these numbers are attached by addition, we say that it's arithmetic. So you could either circle it or you could write it on the line. It doesn't matter to me. Okay. So since it's arithmetic, it's going to have a common difference, d. So I wrote d equals, and I wrote a +4 because to go from the first term to the second, we're adding 4. To go from the second term to the third term, you're adding 4. So then next, I'm going to use the explicit formula. The explicit formula says to find any term number, a sub n, that's to get any term number you want, that equals a sub 1, so that's the first term. So from this list, that's my a sub 1, plus the common difference, so in this case it was a 4, parentheses n minus 1. Now again, if it said find the 7th term, I would plug in n equals 7, but here it's saying write it for any term. So we're just going to clean this up a little bit. We distribute the 4. And so we get to here, and then we're going to combine like terms. So this is my formula for any term. Now, again, if I wanted to find, you know, the next term, which obviously we could just add 4 to that, and we know the next term would just be a 6. Well, let's just check it. So that'd be the 4th term. So if we plugged in a 4 there, 4 times 4 is 16. 16 minus 10 would indeed give me 6. So you can kind of check it to make sure that your equation works. Okay, moving on to example 2 then. So the first thing we do is look at the list of numbers and we try to figure out how are they related. So how do you go from 11 to 8 to 5? Well, you're subtracting 3 each time. So because you're subtracting, that means it's related by addition or subtraction, so it's arithmetic. Remember, geometric is related by multiplication, but this list of numbers is found by subtracting 3. So that means we're going to have a common difference, and in this case, it's going to be a minus 3. So we're plugging it into that explicit formula. It says a sub n. To find any term, you take the first term. A sub 1, in this case, happens to be 11. And then my common difference is minus 3 there, and parentheses n minus 1. So you distribute the negative 3, and then combine like terms, and that gives you this equation. Okay? So we'll just take a pause there to make sure you've got all that down.